in this video starting with the core. Um, so the core reference, let's find out if there is any, or let's just go for it. So, all right, so ig.core is defined in the impact module, and the description is the IG object provides the module definition and loading capabilities, as well as some of the utility functions. All your code should be wrapped in modules so it can be properly loaded and baked. IG is not an instance of ig.class, but just a simple JavaScript object. Oh, okay. That took a while and went over to where I was trying to go. IG is not an instance of a ig.class, but a simple JavaScript object, and thus can't be subclassed. Now, the module definition starts with defining name and requires and defines, like we have talked about earlier. So we're going to skip over that because we already talked about it. The name of a module directly corresponds to its file location and name. Example, the file lib mygame myfile.js must define a module with the name mygame.myfile so it can be properly loaded from other modules, right? So basically the namespacing is specifying the directory structure is what it's saying. Now you can put multiple modules into one file, but be advised that a module is referenced from an external file must have its own file. Ideally, we're just going to put one module in a file. Properties are IG baked set to true by bake PHP to skip unresolved dependencies. Check when loading modules. The default is false. See baking. So baking is basically minifying your game. ig.game is the currently running game instance as created by ig.main or system.setGame. If no game has been started, then ig.game is null. ig.global is the global context object, same as the window when running in a browser. No cache is an empty string by default when the site is loaded with game.html ? No cache. Then no cache is true is called, and no cache is set to a random parameter like ? Some number string to be appended to the URL to bypass the browser's cache. This is used by all of Impact's loading functions, module loading images and sounds. Prefix is used for all paths when loading modules, files, or assets. By default, it's an empty string. So the value can also be set through global impact prefix equal variable before loading impact. This is, for example, useful if you want to run your game on a page that has a URL of /page equal 42 while the game is located in games Pong. And version. So the version string and UA, user agent string, iPhone, Android, mobile, pixel ratio, screen width, screen height. So these are things to kind of optimize the game to work on various devices, to have the right resolution, things like that. So, I would say more than me we're already there. So touch device, Windows Phone, like if it supports touch or not. Main function, this is the key function that we saw for starting our game up. Takes the canvas object, takes the game class, the frames per second, width and height of the canvas that we would like to use, and the scale defaults to 1, the loader class, which is basically a subclass of the IG loader to act as the preloader. The default is the IG loader class itself. And in the later versions, the FPS parameter is ignored. So you may want to take note of that. It's ignored in favor of request animation frame, and this allows the browser to decide the best drawing interval based on the display's refresh rate. If the drawing interval drops below 20 hertz, the timestamp will be capped at 1/20th of the second, essentially slowing the game down. Example, when only 10 FPS can be rendered, an in-game second takes 2 real-time seconds. Okay? We did speak about it in the max step earlier as well. I think it'll show up again in our timer video. Debug functions are log, assert, show, or mark. And they only do stuff when the debug mode is enabled. So you can safely call them because it's not going to happen in your live prod if the debug is disabled. So utility functions, you've got your dollar selector to get the DOM elements, you've got your $new to create a new DOM element, ig.copy object returns a deep copy of a given object. IGK sort allows you to take an object and return an array and sort it by the object's properties. So for example, here you have an unsorted object with zbaz a bar b foo, and you run ig.ksort on it, so you get back the sorted version, which is bar, foo, and baz, a, b, and then z. All right, and then IG merge basically allows you to take objects and merge them. May be useful for merging settings. No cache when set to true or false. We talked about that. Far down the page am I? All right, not bad. Okay, so native JavaScript object extensions. Impact extends some of the JavaScript's native objects such as number, array, and function. It doesn't extend the object, so you can safely use for in loops, number.map, from min, from max, to min, to max. So basically we extended number because oftentimes in games we are going to want to have minimum maximum ranges. Numbers are not clamped. Number.limit min max, clamp a number to the range of min and max. So 75 with the limit 50, 100 will give us 75, 25 with the limit 50, 100 will give us 50, 150 with the limit 50, 100 will give us 100. So that's what clamping is. Number.round will round it. You can specify the precision. Flooring it, sealing it, to int, to degree, to radian, erasing an item from the array. So these are kind of utility functions. Random, picking a random array from element from an array. Function.bind sets the this inside the function to bind. And function.bind is useful for maintaining this object for methods used in callbacks. With modern JavaScript, though, I would, after ES6, I would say use promises, but it's an async awaits. Now, without using bind, this inside foo inc would refer to the window instead of itself, and when called through set interval, foo.inc.bind foo 1000s. So JavaScript bind stuff sets the this inside the function to bind. So essentially when we do foo.inc.bind and then pass in foo, we're saying this is foo rather than this is window. And global modifiers, impact mixin. Impact mixin object will be merged into the IG namespace before any module loading takes place. This allows you to overwrite Impact's modules code to work with different environments, example Node.js, and Impact prefix. So if present, this string overwrites ig.prefix, and this is basically the core. And then I said we will talk about next game. So we spoke about the core, kind of the environmental things, and then now in terms of the game, we can say that we are going to define in the impact.game module, inherits from IG class, basically has this init function. Here the init function is binding some input keys, like binding the space key to this keyword jump, and then calling load level and level my game 1, or basically level 1. Start your game, and that's the IG main function. So essentially we extended the game class to create my game, we passed it into main, attached it to the canvas at 60 frames per second, 320 by 240 pixels, scaled up by a factor of 2. And this example, this synopsis doesn't use the loader, but we have spoken of the loader before, so the last parameter there can be the loader. Description. Basically, game has update and draw methods, which will take care of your collision detection, checking entities against each other, and drawing in everything to the screen. This is essentially where most of your real key stuff will happen in the game. New IG.game is the constructor for this game. It really doesn't do anything. You can subclass it and provide your own code, but usually a game constructor is called through IG main, like we saw here with IG main canvas my game. So you're not really going to be doing a new my game or anything like that. And then when the preloader finishes loading, and then your game will get loaded, and you can use ig.system.setGame if you want to load another game class into your canvas. The currently running instance of a game class is provided at ig.game, lowercase, to be referenced from entities, etc. Properties. So here we have tons of properties that we can go through. So let's look at it on the left sidebar here first. So we've got properties: auto sort, background maps, background anims, cell size, clear color, collision map, entities, gravity, named entities, screen, sort by, and methods being check entities, draw, get entity by name, get entity by type, get map by name, load level deferred, sort entities deferred, spawn entity, remove entity, run, and update. Let's take a look at run. So run is the main run loop, which basically calls the update and draw methods at the frames per second that have been specified. And the update method is where you set the properties of all the entities that you will want to draw in the next and you can also update the properties of the background map, such as its position, things like that, the tiles and animations. And then in the draw method, you will actually do the drawing of each of the frames. Getting entity by name here can get you the entity with the given name. Will return undefined if you can't find it. You can get entities by type, for example, get all the blob entities. You can get map by name, such as you can get the background map or the collision map. If you want to, for example, in the update, change some property of the map, such as a given tile or its position or things like that. And then loading the level will basically load the level object as saved from Weltmeister level editor, and this method deletes all the entities and backgrounds and collision maps currently present. and resets the screen coordinates to 0, 0 prior to creating the new entities and maps. The structure of the level object as saved looks like this, where you have entities and you have layers. The entities have a position and their settings, and the layers are essentially named, such as background or collision layers. They have their tile sets, they have their data representing where these tiles go, whether they repeat, so you can create an infinite layer. And foreground, it can be true or false. It's going to typically be in the background, I'm guessing most layers, but and then the distance is how far you are from where your screen. So for example, the things that are farther in the background layers, you're going to want to give them a larger distance. Tile size is just how big each tile is from your tile set in pixels. So a layer named collision is assumed to be the collision map for the level. Be careful not to call this method in the middle of an update cycle. It switches out all the entities while they're still being updated and cause unexpected behavior. So use load level deferred instead. We saw an example of this before. Sorting entities. You can resort the entities if you've changed their z indexes. Or if you've added new entities with certain z indexes, because otherwise the new entities just get added to the end. Spawning entities will create new entities and add them to the game world at the given position with the given settings, and the entity is appended at the end. You can call sort entities after spawning the entity to resort the entities by their z index. Removing an entity, you can basically call kill. And I mean, you can use the game world to tell, pass in the entity and say remove this entity, but usually the entity can remove itself when something happens. We spoke of run and update. So what have we missed here? We got all of these: get map by name, get entities by type and name, draw, check entities. Check entities method is called for each frame by the update method and checks all entities against each other, and it uses a special hash with a cell size of cell size to do so. If two entities are overlapping, the static IG entity check pair function is called with these two entities as the argument, and this in turn resolves all the entity versus entity collisions. Okay. Cell size is one of the properties of the game here. So the size of each cell for the special hash when checking and colliding entities. As a rule of thumb, this should be 4 times as big as your common entity size. So example, if most of your entities are 8 by 8 pixels, set the cell size to 32. Don't worry too much about it though, and the default is 64. Okay. So essentially, if you have small entities, like about 4 times the size of a given entity on average is your cell size. All right. So going through the properties now. Auto sort will sort the entities in every frame. So I don't know if this is a good idea unless you have a lot of things which you're setting z indexes to that you're spawning all the time. But this can cause some delay or slowing your game down a little bit. An array of so I would leave it as false. Background maps. We had a whole video on background maps, background animations. We spoke of those. We spoke about how to animate the background tiles and then loading the level. We just spoke about cell size. Clearing color is basically a CSS string specifying the color each frame is cleared with before drawing. And you can set this property to null if you don't want to clear the screen before drawing each frame. The default is black. Collision map. So I don't think you really need to do any color clearing unless you're drawing tiles only on specific places. Now, and just want to have like a solid color background. Collision map, we spoke of it already. But it's basically an instance of the collision map, and if you don't want collisions against a collision map, don't create one. Or you can set this property as ig.collisionMap, that's static, no collision, which is also the default. You can use the game's load level method, and you can automatically load a collision map just by having a map named collision. And otherwise, you can also create a collision map using the constructor. Entities, we have a whole video where we talked about spawning entities, sorting, removing entities into a level, changing their z-indexes, gravity, named entities. So we can set the gravity at the entity level, or we can also set the gravity here at the game level. So if we set it at the game level, it's just gravity that will be applied to all of the entities. Note that the entities can specify a gravity factor as well to be more or less affected by the game's gravity. So like you can say that, hey, you know, everything is impacted by gravity, but a feather falls slower than the rest of the normal things. So named entities are basically entities that have their name property set. You can spawn them and get them by name. The game spawn entity method automatically adds entities that have a name to this object. Screen X, screen Y is the screen's position in pixels. Think of it as the position of a window into the game world. Think of it as a position of a window into the game world, as the position of the window. Okay. Sort by will basically sort the entities by z-index, and you can specify what you want to sort it by. You can also sort entities by positions and get a list of entities sorted by positions if you want. Okay, so that's all for the game class. So we spoke of the core and we spoke of the game. And I guess in the next video we can talk about the system. Although I don't think there's much to talk about. So takes care of the starting and stopping of the run loops, you know, the update and draw. It does the housekeeping for the inputs. So we'll talk about system with the inputs, I guess, in the next video.